Ramaksh Manikvariyava, an assistant professor from Government Engineering College of Daman, affiliated with Gujarat Technological University. Welcome you all back. Today, we are going to see the numerical for replacement theory. In the lecture number 2, we had already discussed what is replacement theory and how it works. So in our lecture number 3, we will see the numerical for solving the replacement model. Now, like we say, replacement is something you need to find the optimum value when you have to replace a certain equipment. Okay, so let's see for an example number 1. So example number 1 says that printing costing rupees 6,500 initially has maintenance and resale value as given below. Means there is a printer machine which is costing 6,500 initially. Okay, and its maintenance and resale value as given below. So this is the table where we are given the value of our resale value and the maintenance of our printer, which is costing us 6,500. So there are years given from 1 year, second year, third year, fourth year, fifth year, 6 and 7 years. So in total 7 years are given to us. Now for that, the resale value of this printer having initial cost of 6,500, for first year it has a resale value of 3,000, right? That means now from 6,500 its value is decreased to 3,000. For second year its value is 2,500. For third year it is 2,000. Fourth year it is 1,500. For fifth year it is 1,000. For sixth year it is 700, and for seventh year it is 500. So as we can see, the resale value for this printer is decreasing as the time goes by. Now for the maintenance cost of this printer. So at the first year, maintenance cost of a printer is 100 rupees, as you can see over here. For the second year, it is 250 rupees. For third year, it is 500. Fourth year, it is 1000. Fifth year, 1500. Sixth year, 1800. And seventh year, it is 2000. So as you can see, in the 7 years, the resale value of this printer, initial having cost of 6,500, is decreased, but the maintenance cost of this printer is increasing day by day and year by year. So what's the question in this? They are saying thus they suggest the optimum time period for replacement. That means we have to suggest them that what is the exact optimum time we have to replace it. Okay, so let's get started. So for solving this replacement model, you have to construct this table. Okay, we will see from first to beginning what are the column and how you have to fill the columns. So first column will be often our year of n years. Okay, so how many years are provided us to us? 7 years are provided to us. So first of all, write down in this column the year number 1, 2, 3, 4, 5, 6 and 7. So these are the years that is provided to us. Now second column will be of an cost. So this is an initial cost. So what are the initial cost of this printer? It is 6,500 initially. So the initial cost will not change no matter what happened. So for either it's for first year, second year, third, fourth, fifth or sixth or seventh, it will be same for every year. So it will be 6,500. So we will do it for all the years. So it will be 6,500 for every year, the initial cost. Now the third column will be resale value. So resale value are given in the following above table, where for first year it is 3,000, for second 2,500, third 2,000, fourth 1,500, fifth year 1,000, six for 700 and 7 for 500. So we have to write down over here. So for first year it will be 3,000. Then for second year 2,500, third year 2,000, then 1,500, फिर 1,000, 700 and 500. Okay, so this is the resale value. Now these values are already given to us, so we are writing from the above given data. Now for depreciation, when I say depreciation, it means the decrease in the cost. Okay, so how much decrease in the cost we has found in this year, time goes by years, so it will be given by C minus S, that is capital cost minus resale value. So what I have to do, C minus S, so this will be equal to this C minus this S. So that will give you an answer, that is 3500. So if you minus this 6500 minus 3000, you will get the answer of 3500. The same way for second year, 6500 minus 2500. So that will give us an answer, that value will be 4000, right? Then the again 6500 minus 2000, so what will be the value will be 4500. Again 6500 minus 1500, then 5000 answer will be. Then 6500 minus 1000, that will be 5500. Then again minus 6500 minus 700, that is 5800. Then 6500 minus 500, that is 6000. So you can see there is a increase in the depreciation, means the value of our printer is decreasing every time. Okay, so this will be the value for the depreciation for every 1 to 7 years. Okay, now the fifth column will be a maintenance cost. Now this maintenance cost is already given in this particular given data. So for first year it is given 100, you can take value from over here. Second year it is 250, third year it is 500, fourth year it is 1000, fifth year it is 1500, sixth year it is 800, then for 7 it is 2000. Okay, so it is already been given to you over here. Now this is the sum of the maintenance cost from 0 to the 7th year. So for first year, what is our maintenance cost? It is 100. It is as simple. Now for second year, if I have to write down the sum of the maintenance cost, then I have to include the 100 also. So 100 plus this 250. Okay, so that will give us an answer, that this value plus this 250, that will give us an 350. So 100 plus 250 gives an 350. Now for third year, also once again 350 plus 500, so I have to get the answer, so it will be around, so it will be 850. Again you have to plus 850 plus this 1000, so you will have the value of 8500. Again 1850 plus by 1500, you will have the value 3350. Again 3350 plus by this 800, you have the value 5150 rupees. This plus 2000, that will give you 7150 rupees. Okay, so this is the sum of the cost by every year. Okay, you have to just plus the maintenance cost from first, second, third and the older down way. Okay, now total cost. So what is total cost? It is depreciation cost plus sum of the maintenance cost. So depreciation cost is this one plus sum of the maintenance cost, that is this one. So the answer will be equal to depreciation cost plus the maintenance cost. Okay, so that will be 3500 plus 100, that will give you an answer 3600. For this 4000 plus 350, right, so it will give us the value 4350. Then 4500 plus 850, so it will give us 5350. Then 5000 plus 1850, so it will give us 6000. So on and on, you have to do it for every year. So this is the total cost. Now an final column will be there, which will give us an idea for the replacement time. It is known as annual average cost. Okay, So for doing annual average cost, what you have to do, you have to simply divide your total cost by the year. Okay, what you have to do, divide the total cost by the year. So for example, first one, that is 3600 divided by 1. So what will be the answer? So we'll say equals to total cost divided by the year. So it will give us an answer directly, 3600. For 4350 rupees divided by 2 year, then what will be the answer? It will be answer 21510. Same way, 5350 rupees divided by 3 year, it will is give us an answer this. Then again, I'm doing for the fourth year, same way, 6850 divided by 4 will give us an answer. So same way, do it for the numbers of years. Now it is an important that the answer is within this column, but how you have to choose? Now you can see there is a 3600 for the first year, 2175 for the second, 1083 for the third, and 1712 rupees for fourth year. But after fourth year, you will see there is an increase. For an example, look over here, there is a increase of 1770 rupees. So it is now started increasing. So what is our optimum time? This particular year, this our year is giving us an optimum time. That means if I replace this particular our what you say, if I replace this with the fourth year, then it will give us the best replacement time. So you have to replace your model on the fourth year of an time. Okay, you get the point what I'm trying to say. So your fourth year will be your optimum value. So you have to write down in the answer that according to the calculation, the fourth year is the optimum period where you have to replace your printer. Otherwise, your cost will start increasing. Okay, so this is the replacement model, how you can do certain analysis to find out that at which time you have to replace your model. So you can write down in answer that fourth year is the year when you can replace your printer with a new one. Okay, now let's go to the second sum. Okay, so what is the second numerical is telling us? We read first that a firm is considering replacement of a machine whose cost price is rupees 12,200 and the scrap value rupees is 200. The running costs are found from experience to be as follow. Okay, so what is told us that there is a replacement of machine to be done whose initial cost is 12,200 and scrap value is 200 are found from experience to be as follow. Now the maintenance cost over here is given to us. Okay, so the year is given to us, the maintenance cost is given to us. So how many years are given to us in this numerical? From 1 2 3 4 5 6 7 8. 8 years are given to us, and for 8 years the maintenance cost is given, that is 200 500 800 1200 1800 2500 3200 and 4000. So first of all, what the question is, when should the machine be replaced? So question is once again the same, that what is the optimum time when we have to replace this machine. So let's start our numerical. So firstly you have to build a column in which the year is there. So you have to write down the year, that is 1 2 3 4 5 6 7 8. Okay, these are the years for that. Now for that you had a given of a initial cost, that is 12,200 rupees. Okay, so again, like for cost, initial cost will be same for every year, so we write down over there. Now in this numerical, what is given, the scrap value is given to, that is 200. Okay, and with without respect to time there is no change. So scrap value is nothing but a resale value, as we had seen in our previous lecture. So resale value is 200 but no year wise given to us. So you all you have to do is you have to write down 200 for every year, so it will be 200. Okay, are we clear to everyone? Okay, fine. Now let's move forward. Now for the depreciation, what is the how we can find depreciation? That means the reduce in the value. So you have to multiply this C over here minus this resale value. Okay, so that will give you an answer 12,000. Now I have to do it for every year. So every year is going to have a same answer because it is going to minus with the 200. So answer will be the same. Now for the maintenance cost, for year wise maintenance cost is given to us. So let's write down. So for the first year the maintenance cost is 200. For second year it is 500. For third year it is 800. For fourth year it is 1200. For fifth year it is 800 or 1800. For sixth year it is 2500. For seventh year it is 2200. And for eighth year it is 4000. Okay, so this is the maintenance cost. Now we are coming to the column number 6, which is the sum of the maintenance. So like we said before also, sum of the maintenance is year wise maintenance. So first year is 200, that is fine, right? Now what you have to add on for the next year. So for the next year, second year, it will be equal to first year of a 200 plus the second year 500. So that will give us an answer. So we will do the same for every year, right? That means we are going to add on 700, 800 plus 1500 plus 1200, 2100 plus 1800. So it will keeps on adding. So this is how you will get the answer. Now total cost. What is total cost? It is depreciation plus sum of the maintenance cost. So depreciation is this one plus maintenance cost is this one. Okay, so we have to add on. So it will be answer will be it's equals to depreciation this one plus this 200. So that will give us an answer of 1200, 12,200. Now you have to do it for every year. So I simply put the equation over here. So I had the outcome. You have to calculate by your calci or some, or whatever you are using. Now for the final thing, that is annual average cost, right? What is annual average cost? It is total cost divided by the year. It is total cost divided by the year. So it will be equal to this total cost divided by the year. Okay, so that will give us an answer 12,200. Now let's do for all the year and we had a value. Now let's see how long it is going down and then suddenly increases. Okay, for this point 12,200, second year 6,350, so it is decreasing, and third year 4,500, the then fourth year 3,675, and fifth 3,300, then 3,166, and then you see in the seventh year it is increasing again 3,171, then 3,272. So what is the time good time for replacement? So we can say that the sixth year is the best time for replacing our model, right, or our machine, you can say. So this is how you can finalize that at what time you can replace the machine. In this example you have to replace the machine at the after the 6th year. Okay, otherwise your cost will total annual average cost will increase. Okay, so this is how you can find out and replacement time for a certain equipment which you have to replace individually. Okay, so very clear that this is kind of a individual where you can see there is was a printer, now there is a machine. But in the next lecture we will see how to solve a replacement model which is given in a group replacement. Okay, so we will find out that also in the next lecture. I hope you had cleared out all your doubts. If you had any question or query, please comment in the below. So I thank you so much and let's see you in the next lecture.